Guys, can you see my screen? Let everybody join. Wait for some time. Okay, so okay, sufficient, right? Okay, back to कल doubt रह गया था because I could not find. So I today discussed with the chief engineer of container ship only. So this is the one, right? He told me that okay, the length which you take is from here, the length of the ship, right? Sorry, the length of the container. It is over 40, right? It is 20 for this one series. The yesterday which you are looking is ये जो हम देख रहे थे, that was the from the inside corner to corner. Okay. Actually इसमें क्या देखे है? In your this 40 feet, right? अब अभी आप अगर देखोगे, there are three categories given: 8 foot, 8 foot 6 inches, 9 foot 6 inches. Can you see, guys? दिख रहा है आपको? अगर इसका height में देखोगे, there are three categories, right? Guys, can you hear me? Hello. Is the person there जिसका doubt है container का? Is he here? Okay, so one is this 40, right? Okay. Anyway, ये 40 है एक, okay, and 20. That is clear. If you want to see the height, right? देखिए, यहाँ पे there are 2-3 categories. One is 8 feet in the bottom right. यहाँ पे there is one 8 feet. Okay. Then there is 8 feet 6 inches, 9 feet 6 inches. Can you see? दिख रहा है आपको? Height में. Hello. Guys, can you hear me or not?
Yes, sir.
Okay.
Yes, sir.
So, okay, this is because, you know, because there are 3 different designs of the ship. Sorry, of the container. This normal 8 foot is a standard container. The other 2 categories, they are called as a high cube container, right? इसका क्या होता है, जो height है थोड़ा ज़्यादा रहता है. See, this is the one, high cube, right? High cube container. So high cube containers are similar in structure to standard containers, but taller. Okay, the height is more. Height का कोई constraint नहीं है in the ship. If the because cell guides are made in that way, right? आपका अगर length और width थोड़ा change होगा, it will make a problem. But height is not a problem. Okay, that is why you might have seen some containers are up and down from the top, right? थोड़ा बिल्कुल same नहीं रहता है, हल्का 1 feet up and down sometimes it's there, right? तो ये किसके लिए use करते हैं? Mostly for the voluminous cargo, means which are light in weight but carry light in weight but have more volume. Okay, उसके लिए use करते हैं. This is your high cube container which you are saying. So we will not see that, right? हम सिर्फ standard में focus करेंगे. So your size is 8 feet by 8 feet. Width भी आपका कितना है? Again 8 feet, right? Width also again 8 feet. This is also again 8 feet and 40 feet. For 20 feet or footer it is, I'll just show you from here. Length is 20. Okay, it is 20 feet and 28 by 8. Okay. अब इसमें exactly क्या है? Okay, 28 by 8, right? 19. अब इसमें क्या है यहाँ पर? It is there was a small amount of tolerance given. अब ऐसा नहीं है you should be correct by the last mm. ऐसा नहीं है. Okay, so if you see here also in the width, you see here -5, मतलब 5 mm का आपको डिफ्लेक्शन अलाउड है. ओके, -5, इट कैन नॉट बी प्लस, इट कैन बी माइनस. ओके, इतना टॉलरेंस आपको अलाउड रहता है. यू कैन मेक योर कंटेनर 0.5 सेंटीमीटर स्मॉलर, राइट. आप उसको 5 mm छोटा कर सकते हो. ओके, तो आपका 0.5 सेंटीमीटर 0.5 सेंटीमीटर हो गया, है ना. सेम वे देयर इज अ टॉलरेंस फॉर योर length also. Okay, -10 means 1 centimeter, it can be little bit smaller. अगर एग्जैक्ट नहीं है, थोड़ा सा आप टॉलरेंस इसमें अलाउ करते हो. ओके, एंड द सर्कुलर नंबर व्हिच आई एम टीचिंग इज सी दीज आर द, जो हमारा सीरीज 1 है, दैट इज फॉर द, यू कैन सी, intended for intercontinental traffic, means shipping containers, right, which go over from one country to another, from one continent to the another, है ना. So this is the document for that. It is the ISO standard. You can write the name if you want. Okay, ISO standards 688/2020. ये वाला रेफरेंस है, अगर आपको देना होगा you can give this reference. Okay, this is the ISO standard to which the containers are built. It is a 2020 edition of that. Okay guys, so the dimensions are 20 into 8/8 and 40 into 8/8. Okay, and little bit of tolerance is given in the construction. Okay, 5 mm and 10 mm, 5 mm in the height and width and 10 mm in the length. Okay, उतना आपको थोड़ा tolerance allowed होता है. Okay, this is the standard for the series 1 freight container. Okay. So shall we proceed back to yesterday topic? Okay. So yesterday we did, okay, yesterday we saw the basic definitions, right? We saw the definition of your after perpendicular, then we saw what is forward perpendicular. The distance between both is called as a length between perpendiculars, right? Then we saw the length overall. Then we saw what is the draft, right? What is draft and what is freeboard, वो आपने कल देखा था. Okay, what is draft? Basically it is the draft, क्या होता है? Distance from the vertical distance from the
water line to the
keel to the
attaining
water line, right? Okay, and which is in air, that is the, means outside, that is freeboard. Distance from the water line to the side of the main deck. Okay, side of the main deck, that is a continuous weather deck, उसको बोलते हैं main deck, है ना. Then we saw what is a camber. It is the raise of the height, right, in the center, the curvature. Okay, कितना आपका height raised है, this is called as a camber. And the invert structure, that is called as a tumble home. Okay, this is a tumble home, right? ये देखिए, this is a tumble home, right? This is the actual ship which was coming. Okay, you see, this is the actual ship, right? Normally कैसे जाता है? It should have gone like the red path, right? ऐसे जाता, but it is little bit curved inward, right? They say it is for the appearance of the ship, for better appearance of the ship, and sometimes it's also for the, I've read it somewhere, it is also for the port में कुछ attachments हैं, like you know fenders or whatever, कुछ अगर आपका है, थोड़ा आपका उसका distance रहता है. And camber is there to facilitate the drainage. Okay, otherwise water may accumulate on the top, right? And it will cause the loss of stability. Okay. Then we saw what is freeboard. Okay, difference between, and then we saw why tankers have a lesser freeboard as compared to the bulk carrier, है ना. Then we discussed about the lines plan. This was the lines plan, right? It is a representation of hull. Okay, what we do is that we will cut our ship in different sections and then we will try to make it a graphical representation. Usko bolte hain lines plan. Okay. Now let us start with the basic naval arc. Right. आपको definitions पता हो गया. Now I'll bring you to the basic naval arc. Right. Like coefficient of form क्या होता है, meta center क्या होगा, center of gravity क्या होगा. Okay. All that we will see. I'll switch to reads now. It is a very good book actually. ये वाला एक नया book है. Okay. First of all, we'll see the form coefficients. Important question पूछते हैं. Okay. So let me take just example. First one is a block coefficient. Okay. First one is a block coefficient. As the name says, block means some kind of rectangle, right? Block coefficient. What you do here is that you take a box. Okay. Just think it is a box and try to fit your ship inside it. Okay. Suppose you have a box, इसका एक length होगा, right? There will be length for it. Let's say this is the length of the box. Okay, this is the breadth, right? Okay, let me just show you the definition. Okay, for real ships, the underwater volume can be found using a value known as block coefficient. जो आपका hull का form है, how the hull is looking, it can be known by the block coefficient. Not just block, also we have different coefficient. उसका combination use करें. The block coefficient measures the actual underwater volume compared to a box-shaped vessel of same length, beam and draft. Okay, that is the block coefficient. See here, what they have done is that this is a ship, right? They have tried to fit it in the. Okay, this is the. They have made this box, right? ये देखिए, ये शिप को किसमें फिट किया है? एक बॉक्स के अंदर फिट किया. ओके, टिल द वाटर लाइन, टिल द समर लोड लाइन, राइट? Now you will compare. Okay, see, this is the block, right? Box. So you will fit the ship in that, and now you will see how much is the empty volume remaining. उसका ratio लेते हैं. Coefficients are just a ratio. Okay. It measures the actual underwater volume compared to a box-shaped vessel of same length. Okay. Beam and draft. What is the formula of a cube? Formula of cube क्या होता है volume का? Length into breadth into depth, right? By this we'll get the formula of the block, right? ये आपका block कैसे आएगा? Now let's see the related to the ship, right? Let's say the ship's length is L, right? Ship's length is L. Into breadth क्या आपका? Beam of the vessel, the maximum beam of the vessel, right? That is B into the draft, this much from here to here. Okay, तो उससे आपको volume मिलेगा, right? Into draft. Okay, that is the volume of the ship, right? जितना आपका नीचे पानी में डूबा होगा, almost, right? So उसका volume लेंगे and you will put the lower one on the top of this, right? इसको जो न्यूमिनेटर में रहेगा वो नीचे में आपका ब्लॉक आ जाएगा L into B into D, right? It will be always less than 1, right? जो आपका बार जो होता है, right?
ये कलर में कुछ दिख नहीं रहा सर.
Okay, sorry. Okay, I'll just try to draw on my notebook also. Right. ये देखिए आपने ब्लॉक ले लिया, right? Now suppose you took a ship, right? You took a ship. This is the, let's say, the ship, right? You took this ship. Okay. Now you take this ship. Okay, you take this ship and you try to fit it in this, right? In the box. You lift this whole ship and try to fit it in the box, right? Just imagine I am fitting it in the box like this. समझ रहे हैं आप? Okay, suppose I
हाँ,
fixed it like now some part will be on the top, but I will take only till the water line. Okay, जो नीचे का part होता है, I will take only till the water line. ये मेरा ship थोड़ा छोटा है, ऐसे ऊपर तक रहेगा. Okay, so जितना part आपका पानी का इसमें draft आएगा, that one, the total length of the vessel, right? Like I took over here, and the beam of the vessel. Okay, that I will take. Okay, idea like what is block coefficient? It's a ratio of that. Finger is slipping a lot. So just notes cover. आपको ये इतना clear हुआ guys? So block coefficient is generally आपका जो block coefficient होता है, it is always less than 1. Okay. Now just tell me which of the vessel, a bulk carrier or a container, which will have more block coefficient? किसका ज्यादा होगा? Bulk और container में किसका block ज्यादा होगा?
Containers.
See, I would like to tell you, like, if you need block coefficient more, your vessel should be more like a cube, right? More box. Okay, I'll tell you. Have you seen box barges in the ports? देखा है आपने ऐसा barges होता है, that they're made like a box, then they are towed by the tugboats.
हाँ,
देखा
yes, sir,
आपने?
bunker barges.
They have their block coefficient almost equal to 1 because they're made like a box. Okay. So see, CB का formula क्या it is? When I multiply the draft into the width into the length, what I get? I get the underwater volume, right? That is denoted by navla. This inverse triangle is called as a underwater volume, right? Underwater volume divided by length into breadth into the depth, right? Okay, ये आपका जितना ब्लॉक का कंप्लीट लेंथ कितना है, आपके बॉक्स का कंप्लीट ब्रेड्थ कितना है, और आपके इसका डेप्थ कितना है. ओके, दैट इज द दिस इज द डायमेंशंस ऑफ द बॉक्स. ओके, एंड दिस इज द डायमेंशन ऑफ द शिप. So that is the block coefficient. Formula of CB is equal to, please write this formula, right? Underwater volume divided by length into breadth into depth, right? It is of the box. समझ आया आपको इतना guys? Okay.
Yes, sir.
Now just try to see, right? Just try to think. This is a bulk carrier. Bulk carrier कैसा होता है? If you see from top, it is like this, right? Bulk carrier कैसा होगा? It will be like this. थोड़ा सा ऐसा, and it is like this, right? And जब वो container होता है, that is very fine in the initial, right? बहुत fine होता है. तो containers जब आप block में डालोगे, when you try to put a container ship in this, the empty space will be too much, right? So उसका numerator कम हो जाएगा. So उसका block coefficient कम होता है. The lesser is the block coefficient, the higher is the speed of the vessel. Okay, because see, box. Just tell me, if you make a ship, one is box barge and one is a container ship, right? Of the same size, same dimensions. You put same engine power in both. Which will go at a higher speed?
The
Container
one which
will go
has
at higher speed,
lesser.
right?
Yes, sir.
Because it is more finer, right? So same way. Okay, so naval vessels have very less block coefficient, right? Naval vessels have very less block coefficient. Okay. Okay. So that is your block coefficient. Okay, you see underwater volume of the vessel. Okay, on the top, LBR water line beam of the vessel in meters, right? So you are just taking it as a box. Okay, then water plane area coefficient. First you were talking about volume, now you will focus on the area, right? If you see the exact shape of this, right? Suppose this is the shape of a vessel, you will see from the top, right? So this is the shape of the vessel, right? Let's say नीचे से है, बिल्कुल नीचे से आप ऐसे देख रहे हैं इसको, है ना? Now what you will do here is that you have to calculate area. Okay, how do you calculate area of a water plane in the ship, right? कैसे करते हैं calculate? वाटर प्लेन एरिया कैसे कैलकुलेट करते हैं जनरली?
सिम्पसन रूल डालेगा.
Yes, Simpson rule, right? So what you will do is that you will take this extreme length, that is L, into the breadth. तो आपको स्क्वायर का एरिया आ जाएगा ना? That is how you will get the area of this. And water plane area is by the Simpson rule. So just multiply it, sorry, divide it by that, right? So water plane area AW divided by length into breadth. That is your water plane area coefficient. पहले आप वॉल्यूम में थे ब्लॉक कोएफिशिएंट में, नाउ यू आर इन द एरिया. समझ आए? पहले वॉल्यूम में थे, बिफोर इट वाज वॉल्यूम, नाउ यू हैव कम टू एरिया. वाटर प्लेन एरिया कोएफिशिएंट L into B into D. ओके, पहले 3D में थे, अभी 2D पे आ गए, राइट? Then amidships area coefficient, what you will do is that you will cut your ship at the half, right? You will see the midship section in the other vessel, right? Transverse section आप देखोगे, this is the transverse section. Okay, this is the transverse section which you are looking at. So in this case also you will calculate, it's a again 2D area. इसमें क्या है? You have to, let's say this is the ship, right? This which you are saying is this is the ship, right? ये आपका ship है. Okay. In this case again you will calculate the area, that is your, this is the midship area, right? Again you can use the Simpson rule divided by, this is the complete breadth, दोबारा compare करेंगे into the draft, right? So B depth, sorry, B into D upon ऊपर में midship area. Midship area. Okay. So basically ये जो तीनों coefficient है, they are just telling the hull form, आपका ship कैसा दिखता है. Okay, what kind of ship it is, it will tell you that. Okay, because bulk carrier will have a higher blow coefficient than a container, and naval vessel will have a least blow coefficient. So they will come to know that it is a fine ship, right? Fine bow lines. Okay, so उसकी वजह से क्या है? Because of that, the ship will go at a higher speed, जिसका blow coefficient कम होगा. Because water resistance, the wave resistance will be less. Okay, so it will go at a higher speed. Okay, now let us just take a complete ship. आपको ये तीनों clear हुए? Guys, is it clear? Amidship, water
Yes,
plane area, and your this block coefficient. Okay. Okay. Now this is, let's say this is a ship, right? Actually, it's actually a ship. So you just take it as a reference. I'll just try it. You see the blue one, right? Yes, I'll draw it on now. So this is a complete ship. You will take the midship line, right? Just the length, let's say this is side 100 meter. Here also 100 meter. Okay. This is the last length between perpendicular after 200. So this is the midship. Now, what is happening here is that there is something called as a center of flotation. Okay. What is basically center of flotation? If you pinpoint that, means वो वैसा point होगा जहां पे आपकी सारी flotation forces act कर रही हैं, right? You know what is a centroid, guys? Centroid पता आपको? Okay, you might have seen, right? The people rotating the notebooks on their hands, on their finger. आपने देखा होगा, है ना? So what they do is that they position their finger on the centroid of the plane. That is why it is balanced. Okay, that is why it is balanced. तो अगर आप उस point पे weight डालते हो, if you put your weight on that point, right, on the longitudinal center of flotation, your vessel will not trim, but it will change the draft. Wait, थोड़ा आपको difficult होगा समझने के लिए. I'll just tell you. Okay. Next is your LCF, that is your longitudinal center of flotation. Now let's say ये मेरा एक ship है, right? This is my ship. Okay, let's say this is the midship. Okay. Now suppose I take a block of mass and I put it over here. Okay. Let's say this is the water line, right? Okay, this is the water line. Now let's say I put a block of mass m here, right? यहाँ पे mass डाल देता हूँ. So what will happen? Will the trim change or not? Guys, you know what is trim? The difference between
Yes,
the
sir, it will change.
forward draft and
Forward and after.
after draft, right? Okay, let's say it is 10 meters here and here also. Let's say it is 9 meters. Okay. Now after that, what I do? I will put a block, right? Let's say I put a मैंने यहाँ पे mass रखा. So what will happen now? Because of this mass, what will happen? The aft draft will increase, correct? Will it increase or not? Your ship will behave like this, right? It will be like this now. Oh, sorry. It will be like this, right? It will go like this. Yeah, so हो जाएगा ship आपका. Aft में आपका draft क्या हो जाएगा? Increase कर जाएगा. And in the forward, that draft will reduce, correct? The ship will trim again more. So it is, let's say 12, and here it is, let's say 7. Are you okay with me, guys?
Yes, sir.
Okay. Now let's say I take this mass, right? I take this mass and I move it in the forward. थोड़ा मैं forward move करता हूँ. Okay. I move it here. So will the trim again change? It will change, right? ये थोड़ा आगे में आ जाएगा. Now what will happen is that the vessel will again go little bit up again. थोड़ा ऊपर चला जाएगा और. Okay, थोड़ा ऊपर आ जाएगा. Trim will again reduce. The aft draft will reduce, right? Again, थोड़ा आपका कम हो जाएगा because ship क्या होगा? आपको जितना ज़्यादा sink किया था वो थोड़ा ऊपर आ जाएगा, है ना? Now let me ask that suppose this is the same vessel, right? Suppose if I find a point, there is a point, right, where there is the center point. This is the, let's say, midships. Yeah, midship, but this is not a center point. Let's say I come to a point, I find a point, let's say over here, right? ऐसा एक point है या फिर कहीं भी हो सकता है. If I load the vessel here, what is happening? जो आपका draft था, let's say here it is 10 meter and here it is 9 meter. Let's say I will put the mass here. What is happening? The vessel is not trim. Vessel will not trim, but it will increase the complete draft. Let's say the 10 will become 12 and 9 will become 11. No change in trim. Trim is not changing, but the new draft is coming, right? आपका draft change हो जाएगा completely. Why? Because mass has been added. आपको समझ आ रहा है? I will tell you why. Because you are adding at the center point. समझ रहे हैं आप? You're adding it at the center point of the vessel. That point is called as a longitudinal center of flotation, LCF. समझ आया नहीं आप? Please ask me. Shall I repeat, guys? Is it clear or not? Shall I repeat? Please tell me.
Sir, Abhi, it is like if we are adding a weight and it considered to be acting at the complete area. ऐसा बोलना चाहिए.
नहीं ऐसा नहीं है. See, complete area तो ठीक है. देखिए, suppose you take this log, right? Just think it's a log of wood. Just imagine it's a log of wood. कभी-कभी क्या है? Suppose you are in a boat, right? If you put your feet here in this point, the boat will lift to this side, correct? Then suppose you put your foot on the, let's say on this side of the log, your boat or log will move this side, correct or not?
Yes, sir. Yes, sir.
Okay. Now suppose you put your foot in such a way that, let's say in the exact center point or some point of the center, right? Where what is happening?
Yes, sir.
The log is not moving here and there, but it is dipping more in the water. The
Yes, sir.
draft is increasing, but there is no change. It means at exactly balanced point you are putting.
So it means that is the point where we consider that the center of gravity is acting.
That is actually center of, that we'll see later. I'll tell you. But have you understood LCF?
Yes, sir. Yes, sir.
Okay, I'll come to that. Okay, I'll come to that now. Center of gravity and all I'm going to start. Okay, this is the LCF. Okay, LCF is not to be supposed always at the midship. It can be after the midship also, forward of the midship also. हमेशा बीच में नहीं होगा. Okay, it can be after also, it can be forward also. Okay, because हो सकता है आपका पीछे में mass ज़्यादा because of the machineries, right? And maybe in the forward it is less. Okay, so that is LCF, right?
सर अभी इसको डेफिनेशन में क्या लिखेंगे सर? डिफाइन एलसीएफ पूछा गया तो
मैं आपको बताता हूँ. LCF is the pivot point of the vessel when trimming. Pivot point means the point from where the vessel is trimming. Okay, समझ रहे आप? It is the center point or the pivot point from where the vessel is. See, it's like a fulcrum.
Okay.
लीवर का fulcrum होता है ना, जहाँ पे vessel आपको ऊपर नीचे जाएगा. That is the pivot point. Okay, getting my point or no? It is a
Aye,
pivot
sir.
point. Okay, it's a
Aye,
pivot
sir.
point from at which the vessel will trim. Okay, now let us go get to the real business. That is your center of gravity and all, right? Okay. Okay, actually, in your ships, we have two types of forces. One is a force of buoyancy, and one is a force
Gravitation.
of gravity, right? I'll just tell you in brief. Okay. Suppose I'll show you the transfer section. Okay. Suppose this is your ship, right? Okay. This is your ship. Now, इसको याद रखने के लिए, okay, let's say, what is the bottommost part? It is called as a keel, correct? If I'm not wrong, K. Correct? Now, let us draw a straight line from here.
Yes, sir.
Okay. Now, the point where the all buoyancy forces are acting, right? Let's see the water line. The point where the all buoyancy forces are supposed to act, or it's the center point of the buoyancy lines, right? All देखिए यहाँ से भी आपका buoyancy force लग रहा है, यहाँ से भी लग रहा है, यहाँ से भी लग रहा है, right? Your ship is symmetric, right? Correct? If I'm not wrong, ship is made symmetric. One half of the ship, this side is similar to the other side, correct? Ship is always built symmetric. So when your
Yes,
ship
sir.
is stable, right, in the neutral means in the normal upright condition, this is the upright conditions. Upright means there is no angle of heel and no angle of rest. Okay. So here, the area here, you just see, this is the waterline. Here the area is same, A1 is equal to A2, correct? यहाँ पे दोनों area same है ना? So the complete, let's suppose that the complete buoyancy force is acting at a point, right? Let's say that is the resultant point. This is B. This is called as the center of buoyancy. The point at which the whole buoyancy forces is supposed to act. Okay, it's assumed to act. Okay, जहाँ पे resultant आएगा सारी buoyancy forces का, that is the center of buoyancy. Now, because of the weight of vessel also, we have some other point that is called as the center of gravity, है ना? So let's assume the center of gravity is over here, G. Okay, there's a center of gravity, there's a center of buoyancy. Now, what will happen is that, let's say this is your vessel. Okay, you just आपका कुछ vessel list हुआ या फिर आपका कुछ heel हुआ. List is when the angle change is because of the inside movements. Okay, suppose you consumed your fuel from one side. Okay, एक side से आपका fuel consume हो गया और दूसरी side से नहीं हुआ, right? So because of that also the vessel list, right? और आपने water transfer अच्छे से नहीं किया है ना? उसकी वजह से भी आपका हो सकता है. Just a minute. Just want to do something. I want to try it in a content. Okay. Now this is your ship, right? Now let's say we have got some list, right? I will try to. Okay. So I will try to turn the ship, right? Just imagine this ship is rolling, right? थोड़ा सा ये turn हो जाती है, right? पहले ऐसी थी. Now it will turn in other side. Okay. इसको थोड़ा हम list करवाते हैं. Okay, we'll list it little bit. Now let's say the ship got list, right? It listed like this. So let's say this is a new line. Okay. ये ship जो आपका ऐसा हो गया अभी. Now what has happened? If you see the red one, your center of gravity is still there because there is no change in mass. It is just the change in center of buoyancy. Because क्या होगा अभी आप देखिए. If you see this, now this side the area is more, right? यहाँ पे क्या हुआ? इस side का area जो है वो ऊपर चला गया, है ना? ये छोटे में बताता हूँ, just a minute. This is one. This is another, right? पहले कैसा था आपका? दोनों साइड आपका एरिया सेम था, A1, A2. Now the water line is still the same, right? Water line अभी भी उतना ही है, correct? The water line is still the same, है ना? Okay, but now this here, the water line is A2 is more. तो अभी क्या होगा? जितना आपका ये एरिया था, right? Suppose it has went from here until here, right? So this much extra area, this area has come outside the water. Okay? ये वाला जो एरिया, it has come outside the water, correct or no? And this
Yes, sir.
area, the
Yes,
one
sir.
in the red, it has come down. आपका एक्स्ट्रा एरिया आ गया ना एक तरफ में और एक तरफ में कम है. Because of that, more area means more buoyancy force, है ना? More buoyancy force in this case. So this will have a, अब यहाँ पे जो था आपका लाइन, it will go like this, right? ऐसे है. Now because of this, the center of buoyancy before which was here, it will shift here. Correct or no? थोड़ा इधर शिफ्ट होगा ना, because जिस तरफ एरिया आपका ज्यादा है, होगा या नहीं होगा?
हाँ सर, हाँ सर.
Okay.
इधर.
Okay. Now what you will do
Okay,
is that
sir.
you will draw a straight line from this center of buoyancy. जहाँ से आपका एंगल है ना, from here you will draw a straight line. Okay. Here you draw a straight line, and the point where it cuts, that is called as the meta center. Okay. The straight line you have to draw from the point center of buoyancy, and the point where it cuts the center line, that is called as the meta center. समझ आया आपको? जब आपका center of buoyancy shift करेगा, when your center of buoyancy will shift, okay, you are supposed to draw a straight perpendicular line from the center of buoyancy, and the point where it cuts the line passing through the center of gravity, that is called as the meta center. क्लियर हुआ नहीं हुआ? गाइस प्लीज टेल मी.
सर क्लियर हुआ सर, लेकिन डेफिनेशन में लेकिन हम ऐसे नहीं बोल सकते ना सर, क्योंकि अभी अगर
नहीं वो नहीं, डोंट वरी. अभी उसमें आपको मेटासेंट्रिक हाइट भी पूछेगा, वो मैं समझाता हूँ आपको. ओके, वो
मेटासेंट्रिक हाइट तो फ्रॉम कील टू मेटा सेंटर इज द मेटासेंट्रिक हाइट है ना सर?
नहीं, इट्स नॉट दैट. देखिए एक्चुअल कंडीशन जो रहता है आपका, दैट इज, रिमेंबर, याद रखने के लिए आप ये थोड़ा फॉर्मूला यूज कर सकते हो. केजरीवाल भाई गोली मारे. ओके, दिस इज द एग्जैक्ट कंडीशन. KBGM, केजरीवाल भाई गोली मारे. ओके, वट एवर यू कैन से. ओके, दैट इज केजरीवाल भाई गोली मारे. सो दैट मेटासेंट्रिक हाइट, दैट इज नॉट फ्रॉम KM. Okay, just a minute. This is the called as, KM is called as, okay, I think, sorry, GM is called as a metacentric height. The center between the, sorry, the distance between the center of gravity, okay, and M, that is the metacentric height.
So then the distance between K to M is metacentric, ऐसा है क्या?
Sorry?
The distance between keel to the metacenter point, इसी को metacenter बोलते हैं, क्योंकि ओवरऑल में एक बार पूछा गया था व्हाट इज मेटासेंटर, एग्जैक्टली डिफाइन मेटासेंटर करके पूछा था.
नो, अगर आपको मेटासेंटर पूछेगा तो आपने ऐसे बोलना, It is the point where the center, where a perpendicular from the center of buoyancy intersects the perpendicular line from the center of gravity, जो center line पे है, that is the metacentric height. Because देखिए क्या होता है, first of all like to tell you, whenever your ship list right, तो आपको जो अंदर का
वेसल ट्रिम नहीं हुआ तो भी मेटा सेंटर तो रहेगा ही है ना सर?
हाँ मेटासेंटर तो रहता ही है हमेशा.
हाँ देन अभी जैसा अभी आपने बोला था द पॉइंट व्हिच इंटरसेक्ट्स buoyancy लाइन ग्रेविटी से इंटरसेक्ट करेगा उसी को ही मेटा सेंटर बोलेगा, लेकिन अभी जो यहाँ पे
एक्चुअली क्या
स्टेबल
है,
शिप है
मेटासेंटर कभी भी आपका सेम नहीं रहता, इट विल कीप चेंजिंग. See, metacenter क्या होता है, till the small angle of heel that is up to 10 degrees it will stay same, but after that it will start changing. I can show you the text from read, right, but अभी मेरे soft copy नहीं है. I have the text with me. It has written metacenter is tend to change, it will not always stay constant.
हाँ यस सर,
Okay.
अंडरस्टूड. वो पॉइंट मैंने खुद पढ़ा.
Actually क्या हमने जो किया था, like even when I studied before, when college time में, so we thought that it is always constant. It's not always constant. हमें लगता है ऐसा, but it's not that way. It is only constant till the means negligible change till the small angle of heel, that is up to 10 degree. Okay, you have to say it that way only. It is the point of intersection, right, between an imaginary line drawn. Okay, you can just write the definition. Metacenter, the point of intersection between an imaginary line drawn vertically through the center of buoyancy, right? Okay. And a line through the center of, and the line through center of, again buoyancy when the vessel is tilted, sorry, center of buoyancy. buoyancy का spelling का मेरा issue है. buoyancy when vessel is at an angle or is tilted, right? एक्चुअली क्या होता है उसमें, जब आपका सेंटर ऑफ बॉयंसी चेंज होगा, पहले आपका ये वाला था स्ट्रेट राइट अपराइट कंडीशन में, इट वाज पासिंग द सेम लाइन ऑफ सेंटर ऑफ ग्रेविटी वाले से पास कर रहा था. जब आप इसको टिल्ट करोगे इट विल गो हियर हियर हियर, राइट, तो जहां से भी इंटरसेक्ट करता है वो आपका मेटा सेंटर हो जाता है.
हाँ इसी पॉइंट पे ही पूछ रहा हूँ सर. अभी अपना डेफिनेशन बोलिए कि अगर टिल्ट करेगा एंड इफ द पॉइंट ऑफ इंटरसेक्शन पॉइंट इज कॉल्ड मेटा सेंटर, अगर वो टिल्ट नहीं भी कर रहा है तो भी मेटा सेंटर रहता ही है, देन हाउ कैन वी से अबाउट दैट? मैं तो ऐसा पूछ रहा था, मतलब मेरा डाउट था.
अच्छा, कैसे आप उसका वैल्यू कैसे पता करोगे?
वेसल टिल्ट और हील, then the point of intersection, that is the imaginary line with the point of intersection जहाँ पे intersect करता है अपना normal center of gravity से, उसी को हम लोग मेटा सेंटर बोलते हैं, right ना सर?
Yes, meta center,
It
correct.
is not tilting also, the m meta center is existing में ही रहता है ना, then this point will become
no, it is just a, see, it is just an imaginary point, right? So you have to assume that it has tilted. So तब उसका क्या वैल्यू था? Even if it is imaginary, still it will be at some distance, right? उसमें क्या होता है? We have got some initial metacentric diagram आता है हमारे पास, right? We have something called the initial metacentric diagram. आपको shipyard देता है, उसमें आपको मिलेगा. Wait, I'll just show you. Reads की बुक में है.
Okay.
जो आप पूछ रहे हैं ना, I'll just tell आपका
because
metacentric diagram.
एक सर्वेयर ने यहाँ पे चेन्नई में पूछा था सर, how do you exactly define meta center? हम लोग ने भी ऐसे ऐसे बोला था, he was not like agree with it.
आपको लोकेशन चाहिए उसका?
No sir, he was asking for the exact definition. हम लोग भी यही बोला था, like ऐसा हम लोग tilt करेगा, then the point of intersection, ये ऐसे ही बोला था.
हाँ.
तो he was cross questioning the same point. अगर वो tilt नहीं हो रहा है then the meta center is existing, no, then how will you define the point of, मतलब meta center को क्या करके बोले, अगर पूछा था हमसे.
See, definitions actually the verticals through the center of buoyancy at two consecutive angles of heel intersect at a point called metacenter. अगर आपको define करना, we get it from the metacentric diagram.
हाँ, okay sir.
मैं समझ गया आपका बात. What he's trying to ask you is that, okay, suppose your vessel does not tilts, then how you are going to find the metacenter? Then how will you define that?
Yes sir.
Yes, that is what his question is, right?
Exactly वही पूछा.
Actually, so for that I'll try to find an answer. Okay.
Okay sir, okay.
But this is a definition, right? Actually, that is means आप उसको tilt करते तो किस point से pass करता है. Okay, and see this line also. For angles up to 15 degrees, right? The vertical center of buoyancy may be considered to cut the center line, called the initial metacenter. Okay. So generally छोटे angles में वो change नहीं करता है, but बाद में जब आप उससे ज़्यादा heal करोगे, it will start changing, right? We will see that later. Okay.
Excuse me, sir.
Yes, बोलिए.
सर यहाँ पे वो भी क्लियर कर देना सर, जो एंगल ऑफ लोल होता है ना सर, एंगल ऑफ लोल को भी स्टडी करें तो उसमें लिखा होता है कि व्हेन द शिप इज इनिशियली अपराइट एंड हैज नेगेटिव मेटासेंट्रिक हाइट, तो ये भी वही कंडीशन है कि शिप अपराइट है लेकिन फिर भी वो बोल रहा है कि नेगेटिव मेटासेंट्रिक हाइट. इसका मतलब वहां भी मेटासेंटर है वो.
नहीं, नेगेटिव मेटासेंट्रिक हाइट कब होती है? जब आपका पॉइंट एम गोस बिलो जी.
हाँ तो सर जब
due to any change in loading conditions तभी.
It is all because of the change in loading condition. Okay, first let me just take this, right? I'll go one by one. थोड़ा just have patience, right? You understood what is metacenter?
Yes sir, yes sir. अभी हाँ sir.
Because इसके पहले आपको inclining experiment करना पड़ेगा. Then only we can come to that, right?
Yes sir, yes sir.
Okay, we'll do the inclining experiment में जो भी question पूछते हैं, we'll see that also. Okay. Okay. So this is the metacenter, right? And the point where the whole weight of vessel is acting, that is called as the center of gravity. Okay. Center of gravity is the point where the all gravitational forces is supposed to act, right? Up now इसमें क्या है? Suppose this is your ship, right? This is your ship. Okay. This is the Kejriwal Bhai Godi Mare. Right. Now this is the point of center of gravity. Whenever you are going to load the cargo below the center of gravity, the center of gravity will move below, right? It will try to move to this side, right? G नीचे move करेगा. Whenever you will try to load the cargo on the top, your G will move towards the top. Okay. So अब जो आपका distance between G and M होता है, okay, the distance between G and M, that is called as the metacentric height. Metacentric height. Okay. And it shows how much stable is your vessel. Large metacentric height means the vessel is more stable. Okay. If the metacentric height is more, the vessel is more stable. We'll see that, right? Writing lever and all. Okay. GM is called as a metacentric height, and G is the center of gravity, right? So अगर आप कुछ भी loading करते हो above the center of gravity, that is the, तो आपका center of gravity will shift towards the top, and if you're doing loading below the center of gravity, it will move towards below, right? Now when your vessel tilts, right? देखिए, suppose this is your vessel, okay? Initially, now when it tilts, okay, just imagine it got tilt. ऐसे tilt होगा, है ना? Suppose ये आपका vessel है, it got tilted over. Now at this point, what is happening? Suppose this is the new center of buoyancy here. Okay, let's say the center of buoyancy is here, right? Okay, ये यहाँ पे center of buoyancy है, ये आपका main center line. Okay. अब ये center of buoyancy है. This is the, let's say, this is the G, right? So you take one line here. Suppose your here is M. Just imagine यहाँ पे आपका M आ गया. इतना ऊपर नहीं जाता. Maybe I will just draw it again. Okay. This is G, this is B, and this is M, right? This is the M. Okay. This is a right angle triangle, है ना? Now center of buoyancy. अब यहाँ पे आपको distance मिल गया. Here you are getting a distance, right? Now the center of buoyancy, it is floating up. Okay, center of buoyancy कहाँ जा रहा है? It is going up, towards up, right? And the center of gravity is going towards below, right? जब आपका center of gravity नीचे जाएगा और center of buoyancy कहाँ जाएगा? It will go towards up, right? अब इसमें देखिए मैंने क्या किया? I have kept it center of buoyancy ऊपर किया, right? And another case which should be normal condition is it should be always below the G, right? अगर इसके नीचे रहेगा, इसकी फोर्स कहाँ जाएगी? ऊपर, right? And इसका कहाँ जा रहा है? नीचे. So because of this you will develop a couple. Okay, जो आपका center of this is the center of gravity, right? This is a couple, right? यहाँ पे क्या आपका center of buoyancy ये ऊपर को जा रहा है. Center of gravity कहाँ जाएगा? नीचे जाएगा, right? So it will try to move the vessel in this side. Okay. It will develop a couple, right? G जो होगा हमेशा नीचे act करेगा, and B will always act to the up direction, right? Now if such is the case and the vessel is listed to this side, okay, तो अब क्या होगा? आपका vessel को और डुबाएगा. But when it's the opposite case, now let's say your G is over here, G is this side and B is this side, right? आपका vessel ऐसे tilt हुआ है. In this case your G is acting below, B is going up. तब ये क्या कोशिश करेगा? जो आपका ये वाली जो लाइन है, जो ब्लू कलर लाइन है, इसको कोशिश करेगा इसको सीधा कर दे. It will try to make it upright. Okay. So distance between this, ये जो आपका distance रहता है, this distance, okay, this is called as a righting lever, GZ. जितना ज़्यादा आपका distance होगा of the center of buoyancy from your center line, that is called as a righting lever. Okay. I'll just show you in this. You can see this diagram, guys. Okay. This is the center of buoyancy, right? ये देखिए, ये आपका center of buoyancy था. This is your center of buoyancy, right? क्या pencil काम कर? Okay. This is the center of buoyancy. Tilt किया. This is the new center of buoyancy, right? This is the new center of buoyancy. अभी क्या होगा? This is the old center line और ये आपका new line from your new center of buoyancy, right? So it will intersect at where? At the meta center, correct? ये आपका point of meta center हो गया. अभी देखिए आपका the distance between G from here to this point, इसका जितना ज्यादा distance होगा उतना ही ज्यादा आपका effort लगेगा. B किधर जा रहा है? B is going to the direction, G is coming to the bottom direction, right? तो इसकी वजह से क्या करेगा? जो vessel आपका ऐसे है, it will try to give it a upward motion so that it can righten the vessel. ये जो आपका vessel ऐसे है, you can see over here, G, Z, okay, this triangle, ऐसे है ना ये triangle, okay, this is the Z, this is the G, right? So it will give a couple, okay. इसकी वजह से क्या होगा? आपका vessel इस तरफ move करेगा, it will try to move it upwards. Guys, समझ आ रहा है? नहीं आ रहा है? Okay, wait, I'll start again. ये आपका center of gravity clear हुआ. It will not move because there is no change in weight when your vessel is tilting. Forget about the free surface and all. वो मत सोचिए आप. Center of gravity same रहेगा कि नहीं रहेगा? रहेगा ना?
It has to be same. It has to be same.
Has to be same, right? In ideal condition. Now this much of area, ये जो आपका area है, it has gone up of the water. Okay. And this yellow area, this is the extra area I've got over here. आपको एक्स्ट्रा एरिया मिल गया अंडर वाटर. तो आपका सेंटर ऑफ बुoyancy कहाँ ज्यादा होगा? एरिया किस तरफ ज्यादा है? Here the area is more, right? Here this side the area is more. So because of this, the buoyancy will shift to which side? This side only, correct?
Yes, sir.
Okay. Now it has come to this point, right? This is a new center of buoyancy. Okay, this is the new center of buoyancy, right?
Yes,
ये
sir.
आपका नहीं center of buoyancy. Now what will happen is that center of buoyancy will act which side, upward or bottom?
बॉटम पे सर, जहाँ पे ज्यादा है वहां पे एक्ट करेगा.
नहीं वो तो ठीक है, बट उसका फोर्स किस तरफ होता है? Where is the force of bottom? Sorry, buoyancy.
The
It's
acting upwards.
Okay, you see the arrow here, buoyancy is acting upwards, right? Center of gravity किस तरफ act करेगा?
नीचे.
Okay, because of the weight, right? Center of gravity. So this is the one and this is the other. So it is acting at a distance. एक distance पे act कर रहा है ना?
हाँ सर, हाँ सर.
So just imagine what is happening. This distance is called a righting lever. If this value was more, then the righting force will be much more. Correct. जितना ज्यादा आपका GZ value होगा, उतना ही ज्यादा आपका क्या होगा? Righting moment होगा. This couple will give a force that is called as a righting force, right? And this moment is called a righting moment. Okay. Okay, guys. Hello.
Yes, sir.
Yes sir, yes sir, clear sir.
Okay. So this is the righting moment, right? This is the okay. So इसकी वजह से क्या होता है आपका vessel? It will come back to the original position, right? This GZ is called as a righting moment. Okay. तो इसमें क्या होता है? Okay, understood? This is the righting moment, right? So जितना ज्यादा आपका GZ का वैल्यू होगा, उतना ज्यादा ही आपका राइटिंग फोर्स मिलेगा आपको. Okay. Now this is the stable equilibrium, KBGM, right? Kejriwal by Goli Mare, right? Just remember this, and tomorrow then we'll start with the neutral equilibrium. This Stephen tendency we have to do, and I'll do that. जो आप पूछ रहे थे ना, angle of LOL, that also I'll cover tomorrow, right? I'll try to cover that, and inclining experiment then we'll start, right? I'll try to cover that tomorrow. आज का आपको clear हुआ what we have done today?
Yes sir, yes.
Okay, this the basic definition, right? You can write this also. इसका screenshot लीजिए, heel and list, ये लिख लीजिए. Okay. Please take a screenshot of this one. This is heel and list. Sometimes they ask, what is the difference between heel and list? Heel जो होगा, that will be because of the external force like wind, waves, right? And list, हम बोलते हैं ना, डेक से कभी ब्रिज से फोन आएगा, प्लीज स्टार्ट द ब्लास्ट पंप, वेसल लिस्ट कर गया 1 डिग्री. बोला आपने, किया, एक्सपीरियंस किया होगा कभी, बोलते हैं ना वेसल 0.5 डिग्री लिस्ट कर रहा है, थोड़ा पोर्ट में विल ट्रांसफर वाटर. हैव यू सीन दैट? और विल से विल पंप आउट. कभी हुआ आपके साथ? हेलो.
Yes, sir.
ओके. रिमेंबर चीफ ऑफिसर क्या बोलता है? लिस्ट किया, राइट? ही नेवर सेज वेसल हील कर दिया, है ना? बिकॉज इट इज डन बाय विद इन द शिप, आप वेट चेंज करते हैं, है ना? इट इज बिकॉज ऑफ दैट. ओके गाइस, सो आई विल सी यू टुमारो, राइट, एट सेम टाइम. ओके. ओके गाइस, थैंक यू, हैव अ गुड डे. कुछ डाउट है किसी को? ओके.